Acceleration is the increase or decrease in velocity per unit of time. For example, we have an object at rest, so it has a 0 velocity. After 1 second, the velocity here can be 4 meters per second, and then again after 1 second, the velocity became 8 meters per second, and then again after 1 second, the velocity is 12 meters per second. So from here, we can see that for every second, there is an increase of 4 meters per second in the velocity. So we can say that in here, the acceleration is 4 meters per second. Now we can analyze this one. You can write it as 4 meters per second, but sometimes we can put a denominator of 1, and then meters per second divided by second over 1. So this is division. We can do the reciprocal of this one. So this becomes meters per second times 1 over second. We did the reciprocal of this one, and then from division we made it into multiplication. So the unit becomes meter per second squared. So you can use either meters per second or meters per second squared for the acceleration. So these are the 3 main formulas for acceleration and velocity with time and distance. Example 1. What is the acceleration of a car if the initial velocity is 10 feet per second and increased to 30 feet after 5 seconds? So what is given? Let us write what are the given factors. There's an initial velocity, so that's VI. Initial velocity is VI, so initial velocity is 10 feet per second. And what else is given? So it increased to 30 feet per second. So this is the final velocity, which is VF, 30 feet per second. After 5 seconds, seconds is a unit of time. So your time is 5 seconds. So what is being asked? So find. So what is the acceleration? So what you need to find is the acceleration. Now looking at the formulas, we have the initial velocity, we have the final velocity, we have time, looking for the acceleration. In these 3 formulas, you can see that this is the one that we need to use. So we can now substitute all this given into the formula. Acceleration is, so your final velocity is 30 feet per second minus initial velocity 10 feet per second divided by time. Time is 5 seconds. So 30 minus 10 is 20 feet per second. They have the same units, so we can just copy the units, divided by 5 seconds. So 20 divided by 5 is 4 feet per second per second. So just like here, we can manipulate this. This becomes 4 feet per second squared. So this is your answer. Example 2. An object with an initial velocity of 10 meters per second has a constant acceleration of 2 meters per second or 2 meters per second squared. What is the distance traveled if the final velocity is 20 meters per second? So let's start with what are given in the question. So in here, an initial velocity of 10 meters per second. So that's VI, 10 meters per second. And then an acceleration of 2 meters per second squared. So your A is 2 meters per second squared. So final velocity. So your final velocity VF is 20 meters per second. Now, what do you need to find? What is being asked? What is the distance? So find S. So looking at the formulas that we have, which of these three formulas has all of this? Which has the initial velocity, final velocity, and acceleration, and S. So from here, we can see that this is the formula that we need to use. So we can write it here. Final velocity squared is equal to initial velocity squared plus 2AS. And then we substitute all our given. So your final velocity is 20 meters per second squared. Your initial velocity is 10 meters per second squared plus 2 times your acceleration, 2 meters per second squared, times the distance, which is at the moment you don't know yet. Now when you square the units, you have to when you square the number, you also have to square the units. So this one becomes 400 meters squared per second squared. This one becomes 100 meters squared per second squared plus 2 times 2 meters per second squared times S. So if we move this one to the other side, this one becomes negative 100, so this becomes 300 meters squared per second squared. This one becomes 4 meters per second squared times S. So we can divide 4 meters. So we can divide this one by 4 meters per second squared to leave S. So what happens is 300 meters squared per second squared divided by 4 meters per second squared is equal to 4 meters per second squared S divided by 4 meters per second squared. This will cancel out, and the second squared and the second squared will also cancel out. Let us explain it further here. So you have meters squared per second squared. So this is division. So we do the reciprocal. This becomes second squared seconds squared over meters. We did the reciprocal of this one. So seconds squared and seconds squared will cancel out. Meters, so 1 of meter will cancel out with meter here. What you will have left is meters. So your S, 300 divided by 4 is 75. Now we computed all the units. It became meters. So your distance is 75 meters. Example 3. An object moving at a constant acceleration of 2 feet per second or 2 feet per second squared travels a distance of 160 feet. What is its initial velocity if it traveled for 10 seconds? So we first write all the given factors. Constant, so moving at a constant acceleration, so we have acceleration of 2 feet per second squared. Travels a distance of 160 feet, so we have a distance of 160 feet. What is its velocity if it traveled for 10 seconds? Now 10 seconds is a unit of time. So the time is 10 seconds. So what is being asked? What is its initial velocity? So find initial velocity. Now from these three equations, three formulas, the one that would fit our question would be this one. So we just plug in these values into this formula. So S would be your 160 feet. Initial velocity is still unknown, so we just leave it as initial velocity. Time is 10 seconds plus 1/2. Acceleration is 2 feet per second squared, 2 feet per second squared, times time, which is 10 seconds, 10 seconds, the quantity squared. So we'll just copy this 160 feet, and then we just copy this one, 10 seconds. Now this 2 and 2 we can cancel out. We will have 1 here, so 1 foot per second squared times, if we square this, 1 becomes 100, 10 becomes 100 seconds. We also need to square the unit, so this becomes second squared. Now this will cancel out, second squared and second squared. So what do you have? 160 feet, VI 10 seconds, plus, so 1 times 100 is 100 feet. So second squared is cancelled. And then we can move this one to the other side, so we leave this one. So this is 160 feet minus 100 feet is equal to VI times 10 seconds. So 160 minus 100 becomes 60 feet is equal to VI times 10 seconds. So we need VI. So what's with VI is 10 seconds. So we need to remove this by dividing this by 10 seconds. So we also have to divide this by 10 seconds. So this will cancel out. So initial velocity will be 60 divided by 10 is 6. So your unit will be in feet per second. So this is your initial velocity. Example 4. An object with a velocity of 40 meters per second has come to a stop after 8 seconds. what is the acceleration of the object? So let us first write what are the given factors. An object with a velocity of 40 meters per second, so this will be an initial velocity, 40 meters per second. Now, it has come to a stop after 8 seconds, so it means the final velocity has come to a stop, meaning the final velocity is 0. So, final velocity is 0 meters per second. After 8 seconds, now 8 seconds is a unit of time, so your time is 8 seconds. Now, what is being asked? Find what is the acceleration. So, find the acceleration. So, in our formula, the formula that we need is this one. So, we just substitute the values in this formula. So your acceleration is unknown. So a, your final velocity is 0 minus initial velocity. Initial velocity is 40 meters per second divided by time. Time is 8 seconds. Now, so this has the same unit, so 0 minus 40 is negative 40 meters per second divided by 8 seconds. So, negative 40 divided by 8 is negative 5 meters per second per second. Now we can manipulate this one. So second, we can put a denominator over 1. So the unit will be meters per second divided by second over 1. We can get the reciprocal and proceed as multiplication. So will become multiply and 1 over second. So your unit will be meters times 1 is meters. Second times second is second squared. So your answer will be negative 5 meters per second squared, or negative 5 meters per second. So that is your answer.